Everyone, and welcome to part two. So, how does it affect you, GNSS systems? Well, firstly, you can make money off it. Because it's provided for free, you can essentially make a business out of it. So, the common ones would be Garmin, TomTom, or the more latest ones is Uber, Lyft, and Bolt. So they accurately detect where their drivers are at any point in time inside the cars or based on the GPS device in the phones, and you can then make a business out of it. And it's a multi-billion-dollar business if you want to do the numbers. So something that's provided for free by the US, and you can make money off it. Should Africa build their own? It's quite pricey, really. The US back in 2005 spent $750 million per year. This is to run it. So there's also still to actually develop it. Usually develop once every 10 years. You have new generation has to go up and also other costs involved. So how does it affect you? So there are four main aspects that or sectors that the satellite systems affect us. First one is the power grid. So the generators or everything in the power grid needs to be synchronized. So that includes the generation or the generators, whether it's the solar, wind, coal, the transmission, and the consumption. So all of this needs to be perfectly balanced. If it's not, or if the generators are out of sync, you have issues with frequency that might affect sensitive systems on the grid. This happens with major industries where if the grid is not synced properly, they actually tell them just cut us off. We'd rather have that than sensitive equipment breaking. Two, banking operations. So this is mainly to do with the stock market. So those few seconds that it takes to make a transaction could be the difference between 100 million gaining $100 million and losing $100 million. You need to be able to act quickly and what time these transactions occur. So that's why these transactions go up to like the nanoseconds, hence why we have nanoseconds atomic clocks. Second one, or the third one, should be transportation systems. So this is to do with navigation. So self-driving cars need to know where they are in terms of the road to get to their destination. Smart apps, something like Google Maps, and how it is able to tell, first it needs to know where you are, and then where's your destination, and then what is the best route for you to take to get to your destination. So that's called smart navigation. And another one would be aeroplanes or missiles or rockets. Even satellites even use GPS. So everything needs to know where it is on the earth and then where's the destination is, and then be able to navigate to get there. The fourth one would be communication systems. So how information is transferred from one point to another. So let's say you want to call somebody and you need to know what time you access the tower, how long it takes to access another tower to get maybe to the satellite up in space, and then back down to the ground wherever the call needs to be received. So all of this is critical. I think mostly you might see it in live TV. So when they're actually talking about live TV, there's usually a delay, and it's not that much though. It's about 1/8 of a second, depending on how good your internet connection is. But we've all seen what happens when you start buffering and lagging, and information is not being sent at the right time, and that is basically what buffering is like. Information is not being sent fast enough for you to be able to read the information. So your video buffers, all in all. So another two more applications that are actually used is precision farming, as I mentioned earlier. So the tractor needs to know where it is on the farm and where its area of operation needs to be and how it should move around and know where it's going around. And a nice, interesting one actually is uh, structural bridge deformation. So what happens is here you have your bridge, and here you have maybe the GPS receiver. So what happens is when the bridge starts to deform, the signal takes longer to reach the GPS receiver. Because it takes longer, it means there's a bigger distance, And that bigger distance basically correlates the bridges deforming. So how, just a quick introduction into how you can accurately calculate your location. So each satellite sends out a signal, and because it's moving at the speed of light, and if you know where the GPS receiver's location is, and you know how long it's supposed to take for the GPS to receive the signal, so there's like a slight delay due to the distance, you can then calculate the distance using the speed of light and how long it takes. So what usually happens is like a signal sent, and the difference between the two signals, exact same signals on the satellite and the GPS, and the difference due to the distance, it's usually like 80 milliliter second shift between the waves, and you can use that to then calculate the distance. It's usually more or less around 20,000 kilometers or so. So, and from there you can then calculate your X, Y, and Z coordinates. So just look up trilateration, and you'll sort of see how it works. You need at least 4 to make it work. And that's GNSS systems for this episode. Next week, I'll talk about geostationary satellite systems and how people make money off those and their space applications.